This is a tough question. There's no getting around that, and I know that there's several of you who probably didn't even bother to attempt this. I guess what you need to be aware of is basically just sort of what sort of strategies you can use to solve this. Now, the key part of the question, sorry, I'm using this thing for the first time, so bear with me. Oh no, hold on. Right, sorry. So the key part of this question is ending up with this result, x squared minus 30x plus 45 equals 0. And probably a lot of you are looking at this and going, well, I have no idea where that comes from the question. You've got some information which doesn't really appear connected. You've got the radius of the two circles, you've got this length here and this length here, and probably some of you were drawing in diagonals or maybe trying to do diameter subtends right angle because you saw Pythagoras and we're trying to figure out. I mean, Pythagoras is the key to this. So we know there's going to be a right angled triangle in here somewhere. If you have a look at this x squared minus 30x plus 45 equals 0, you'll note that it doesn't factorize to integer solutions. So that's another clue as well. So where's this right angled triangle going to come from? Well, if you have a look at this straight line, it's fairly likely that this particular straight line isn't going to get broken up. I suppose that's maybe a first way of looking at it. So that would suggest that this is the hypotenuse for a triangle. So if I draw in two straight lines here, or attempt to, let's see how this goes. Okay, let's put in that straight line there, and that straight line there. Okay, well, you know where it's supposed to be, and you know it's supposed to be a right angle triangle. So try and do it properly. Okay, what's up? There we go. That's better. Okay. Okay, it's still on a right angle, but never mind. Now, once you've got this triangle, you've basically solved the question. So I suppose that was the key strategy here, because as soon as you've got that, you can see what's going on. If I write in this length, now this length you know, because the bit that's left over here is the radius of the first circle. So there's 4 centimeters taken off the total width here, and this length here is the radius of the second circle. If I draw in those lines, maybe that's more obvious. So that length is x, which means that this length here is x. That's supposed to be a straight line. Sorry. There we go. That length's supposed to be x. And this length over here is another radius. It's the radius of the second circle, so that's 4. Now, if I put those lines in, you can see that the black line in the middle is the whole width minus 4 and minus x. So if you do 10, take away 4 and take away x, you're left with, change color, 6 minus x for that length. And similarly for the vertical one, this length here is x, and that length, oh god, this diagram's going really badly, sorry. That length there is 4. Why is that 4? Well, this length is 4 and they're parallel. So this length here is 9 minus 4 minus x. So this is now 5 minus x. So out of that horrendous mess, we have a right angle triangle, which I'm going to try and draw properly down here. There we go. Fantastic. Right. So we've got a right angle triangle where that is 4. No. Sorry. Still getting used to this. Right. Let's try it again. 4 plus x. This length here is 6 minus x. And this length here is 5 minus x. Okay, now that's the crucial part to solving this question. Now it's a case of adding the two sides, sorry, squaring them and adding them and making them equal to the square of the hypotenuse. So it's still not completely done yet because we've got to work out what 5 minus x squared is. There's lots of ways in which you can get confused doing that. We've got to do 6 minus x squared, and we've got to make that equal to 4 plus x squared. Now, when you're squaring these brackets out, a lot of people can get confused with what happens. Remember that 5 minus x squared is 5 minus x times 5 minus x. So if I try and tidy this up a little bit, or no, I'm not going to bother because I'm still working out how to do this. All right, so as an example, 5 minus x squared is 5 minus x times 5 minus x, which gives you 25 minus 5x minus 5x and minus 10x plus x squared, because you've got minus x times minus x. And similarly, 6 minus x will give you, sorry, I'm just going to crash over into this next question, 36 minus 12x plus x squared, and 4 plus x, so this is really getting messy now, is going to give you 16 plus 8x plus 4x plus 4x plus x squared. So let's put all that together. That equation is 5 minus x squared, which is 25 minus 10x plus x squared, plus the 6 minus x squared, so plus 36 minus 12x plus x squared is equal to 4 plus x squared, so 16 plus 8x. Whoops. Plus 8x plus x squared. Okay, now that left-hand side, we can simplify the 25 and the 36 added together to make 61. We've got minus 10x minus 12x, which is minus 22x. And the 2x squareds add together to make 2x squared equals 16 plus 8x plus x squared. Now I've run out of space, so all I can say is that if we subtract what's on the left-hand side, that's the equal sign should be here, sorry. So ignore that. If we subtract what's on the right-hand side from the left-hand side, you subtract an x squared, you subtract an 8x, and you subtract 16 from both sides, you end up with this equation. To solve it is just straightforward quadratic formula. So you get 30 plus minus the square root of 30 squared, which is 900, minus 4ac, which is 180. So that's the square root of 720 all over 2a, which is 2 in this case. Maybe I'll just do it quickly up here. So for part B, you should get x equals 30 plus or minus the square root of 720 all over 2, which comes down to 15 plus or minus root 180, which has some square factors, but we'll not simplify it. And the square root of 180 is something like 13 and a half, which means you get something like 28 and a half or 1 and a half. That's an interesting result, actually, because one of those is impossible. And usually when you're looking at impossible values, it's the negative one that you discount, because you can't have, for example, a negative length. That's if you're going to discount it. That doesn't, just because you get a negative result doesn't mean you ignore it. But if you're dealing with length, and x is a length, if you had a negative value, it wouldn't be allowed. But here, interestingly, when you do this, square root of 180, it's about 1 and a half. So the answers are roughly 1 and a half and 28 and a half. I know that's not exact. I should probably have a look at the answers, but I don't have them here because I didn't download them. Now, looking at these solutions, one of them is impossible, and I hope you can see why. The box is 10 centimeters by 9 centimeters, and you've got a length x here. This is clearly the smaller circle. I know the diagram's not accurately drawn, but if that length is 8, because it's two radii, and that's 9, then you haven't got much space for this circle. But anyway, the at the very least, you know that the circle can't have a diameter which is more than 9 centimeters because it wouldn't fit in the box. We've worked out x, which is the radius, and got it to be 1.5 or 28.5. 28.5 is impossible because it wouldn't fit in the box. So in this case, rather trickily, we need to discount this solution. Do make sure that you show that you got it, but the solution that's around 1.5, and I know it's not exactly 1.5, but it's around 1.5 is the correct one in this case. And that's that question. That was easy. No.